Alrighty, hello everyone. It is 10:32 a.m. Saturday, June 7th. I've been up for a couple hours, went ahead and got breakfast and relaxed for a bit, and decided to start my day off with some programming. Now, around 12 o'clock, I plan on going to the gym, so I'm gonna make this not a 2-hour video. So try to cap this at an hour and a half if we can, approximately. So let's try to see if we can get as many of these done as possible. So I did reorder list yesterday. I didn't really do it. Kind of like sat there confused, wrote something that was very similar to what the answer would have been, but wasn't right, and then I just kind of gave up. You know how it goes. So, let's move on. Let's get this done. So remove the nth node from end of list. Given the head of a linked list, remove the nth node from the end and return its head. I feel like recursion would be used for this. You can do recursion. Yeah, let's do recursion. You could also do this iteratively too. With iteratively, you could do like you go forward and then you hit the end and then you go backwards until you hit the nth one and then you kind of return on that. Let's do a node and let's just copy that. Okay, I think I only need that. So I'm basically gonna just return a numerical value, and that numerical value will basically be like where I'm at in this current position. So return it, and then we'll just put target here, just for the lols. So I'm gonna say current value is going to be equal to target. Nope, sorry. It's going to be equal to recursive of node.next. Oh, I'm going to have to write a little edge case with target. Just, do something like that. Say if node is equal to none, which means it's null, and we're just going to return 0. Okay. Then I'm basically going to say if this is where the tricky part is, because you need kind of previous. Okay. If current value is equal to target. Then I have to do a special case, special. So I have to link previous with next. Honestly, I'm thinking iteratively might actually make more sense here. Apologies. We're just gonna do iteratively because I'm feeling like that makes more sense. So what I want to do is I want to go bounce to the end and then bounce back. So say current equals head. While current does not equal none, current equals current dot next, and then we do a previous. Do previous equals none. Previous equals current. Okay, so this will get me to the end. So basically, once I hit the end, then previous becomes my new current. So I'm gonna say count equals 1, and then I'm gonna say no wait this man. Oh, I'm seeing a lot of edge cases here. This is what I hate about linked lists, man. It's like there's always an edge case here or there or here or there. It's just so stupid, man. I gotta find the right way of going about it. I think a really easy way is you could do like a double loop. So you could do something like this will basically just give you the length. Oops, nope, not that one. Oh, I did doubling. Silly. Okay, just count all this out. Sorry, I just want to test my. This gets the length, right? It does not get the length. It's well, not the length. Oh, that's because I'm counting head twice. That makes sense. Okay. So this gets the length, and then then I can do some stupid thing like wall count doesn't equal n. So if n is equal to count, which means this is an edge case, then we're just going to return head dot next. This is an edge case. Well, count doesn't equal n. I'm not returning anything here. This is just a curiosity. Okay. This is pretty jank, but honestly, anytime I do a linked list solution, I always feel like it's super jank. Okay, and that was it. That was the solution. Let's check NeetCode's video, see if that was close. Brute force. Iterative 2 paths. Recursion. 2-pointer. Whoa, 2-pointer. That's smart. Well, actually, how do you get the dummy equals list node 0 head? Oh yeah, you just do n-1. Wait, no, you can't make that. Oh, you're creating the distance between left and right. Dude, that's so smart. What the hell? And he doesn't even do it in the edge cases. That's actually smart as hell. Okay, that's pretty cool. I'm not going to implement that because I already did my solution, but that's very interesting. Okay, next question. A lot of stuff going on here. Dude, I mean, I'm here to code problems. I'm not here to read a book. What the hell is this? Like 4 paragraphs? Are we being for real right now, dude? Come on, man. A linked list length of n is given such that each node contains an additional random pointer which could point to any node in the list or null. Okay, but like, what does this problem even relate to? Like, actually, like in real life, like what? I don't know. Maybe this is some operating systems jargon, but this is random. This is so random. Construct a deep copy? Oh, that's bright. Oh my god, that's bright. And an alternative is a deep copy, meaning that fields are dereferenced rather than referencing to objects being copied. Bro, English? What? New copy of objects are created for any object references and references to these places. Dude, we're using the word reference way too many times in this paragraph. I'm gonna throw something. What does this mean? This is so much. Okay. Yeah, I have no idea what are we even yapping about right now. This does not compute with me, but copy. A deep copy should consist of exactly a yawn apparently. Exactly n brand new nodes where each new node has its value set to the value of its corresponding original node. Huh? Both the next and random pointer of the new node should point to new nodes in the copy list such that pointers in the original list and copy list represent the same list state. What the fuck are we talking about? What is this? None of the pointers in the new list should point to nodes in the original list. So I'm just making a copy, okay? Is this like more confusing than am I misunderstanding? If I literally just return the head of this... Hold on. If I do this... Am I cheating? Oh. This one's a smart problem. Okay. For example, if there are two nodes x and y in the original list where x.random equals y, then for the corresponding two nodes x and y in the copy list, x.random equals y. Return the linked list is represented as the input as the list of end nodes. Each node is represented as... Dude, I literally I don't know, whenever you start bringing up random algorithms, this is getting into probabilistic algorithmic theory, and I hope not, because I'm not trying to do probability right now. Random index, the index of the node from 0 to... Oh my god. If it does not point to any node, your code will only be given the head. What do we... Dude, where... 4 hints? Oh my god. Oh, this is a problem. Oh, you only gave me 3. Okay, I gotta do this. Oh, man. Brother, what am I... Hold on, let me look at the 4 hints here, because usually they're actually tragically trash on LeetCode. Just iterate, bro. Okay. Just iterate the linked list and create copies of the nodes on the go. Since a node can be referenced from multiple nodes due to random pointers, ensure you are not making multiple copies of the same node. Right, yeah, that's the issue. Dude, I don't even know where to begin with this. This is so, I've never seen anything like this before. I don't even want to do this problem. This problem Loki is just, kind of nasty looking. C. Dude, I don't. This problem is like not fun. There's an extra random pointer for each node, and unlike the next pointer, which can point to the next node, random pointer can point to any node in the list. A deep copy is meant to create completely separate nodes occupying from memory. Why can't we build a new list while iterating through the original? Well, because you can create copies of the copies, which would be becoming improper, and then it would unlink the linked list, and then you would have a whole lot of jargon. While iterating through the list, when we encounter a node and create a copy of it, we can't immediately assign the random pointer's address. Right. This is because the random pointer might point to a node that has not yet been created, and then we would accidentally recreate it. To solve this, we can first create copies of all the nodes in one iteration. However, we still can't directly assign the random pointer since we don't have the address of the copies. Well, so you're saying a hash map? Yeah, that makes sense. But is the value always unique? Because I don't think it is. Yeah, right here, 333. It's not unique. So what are we storing as the hash? This can help by mapping the original nodes to the corresponding copies. This way, we can easily retrieve copies of any node. Wait. Sorry. Let me. This can help by mapping the original nodes to their corresponding copies. Oh! Yo, wait, that is actually kind of smart as hell. Okay. So, current equals head, dude. Oh my god. I hate linked list so much. I hate linked list. No, let's look at this tree. Let's look at this tree real quick. Oh, never mind. I capped. I was about to say, it's so useless. We don't even go straight to trees. I lied. I love linked lists. Yay! Oh, I thought I copied it. Well. Let's try to see if this actually gets created properly. Sweet. Okay. Dude, I'm disappointed in myself for not thinking about the hash set, brother. Hash set is like my goat. That's okay. Copy current equals copy head. I'm basically going to say while current doesn't equal none. Alright, this is absolute word vomit. Alright. Bet. Alright, so I'm gonna call this hash, just because my hash, oh my days. Of course, no hash. Or dictionary, you know. Kick a man while he's down, why don't you, huh? If current dot random, so if it exists, then I'm basically going to say, oh wait, no, I'm capping. Wait, what am I doing? So basically what's happening is my link list, at the moment I store, my next value stores the copied, but the random stores the previously uncopied, the original. So what I'm going to do is I'm going to basically use this dictionary that is a key value pair where the key is the original to the copied, and then I'm going to kind of swap it like that, which hopefully works out. I'm a little interested to see that the dictionary is able to hash if the dictionary is able to hash a class, because a class is not static. It can change. It's not. I don't know. Maybe it's static enough, but we'll see. Maybe it's not the classes like data that we're concerned with, but maybe it's just kind of memory point. I guess as long as it maybe doesn't have a list in it, it's fine, but who knows. Um, the winner takes it all. Oh. Oh my goodness, what am I doing? What's the problem? Key error. What is the um what is the error? Brother, you know, I'm being a vibe coder on this. I'm trying to access a key in the dictionary that doesn't exist. Okay, that's what I was assuming. What would be the problem? The curiosity occurs where it's like, what are we talking about? You know, like. Oh. Okay. That was it. So the error, if you could see, basically, oh. Okay. Dude. I mean, it's always these sons of bitches making this dumbass code stuff. Like, whether head, like, why do we, don't. If head is equal to none, then we're just gonna return none. I mean, like, why? That was dumb. Don't do that shit. That's not cute. What are we doing, man? Alright, whatever. Done and done. That was a stupid problem. I did not like that one. I mean, it was smart, but also dumb. You're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return the sum of the linked list. A single digit? Like no double digit numbers? Is that what we're trying to say? Wait, huh? Oh. Oh, we're doing this mod. Oh. Wait, huh? Oh, carry over. Mother faggot. I don't want to do carry over. Oh. I've done this problem before. I remember this. I did this like 2 or 3 years ago. I remember hating it. We'll see if I still feel the same way. So, this is basically, in short terms, I'm basically doing, the fun QT edition, with a little bit of carryover. So, I do have the potential, like, I have the potential of the list not being the same length, which is not fun, right? Let me see. Yeah, they're not equal. But no leading zeros, which is great, but they're not equal. So, do you have another case? See, voila, here you go. Okay, but what's the answer for this one? Let me just return none. Okay, so it's like, gotcha. So these do end up adding up, no matter what. So, okay, we have 18 carry the 1. Wait, no, this is so weird. 19 carry the 1. 19 carry the 1. 19 carry the 1. 10 carry the 1. 10 carry the 1. 10 carry the 1. 1. Okay. Alright, yeah. No, this is awesome. Round of applause for this problem. Yeah, we love it. We love it, we love it, we love it, we love it, we love it. I wanted to say, I'm going to call this variable carry over. We're going to put that as a 0. Can't do this no more, bro. I'm going to say while li doesn't equal none, and oh no, not li, l1, lol. While l1 doesn't equal none, and l2 that doesn't equal none. Thank you, Zoe. And l2 doesn't equal none. We're going to basically say we're just going to keep continually adding on these values. Oh, and we're going to do a new called a new head type shit. So new head is going to equal. I'm going to just say it's nothing, right? It's a nothing burger at this current time. So I'm going to say new head dot value new head dot value is going to be equal to L1 dot value plus L2 dot value. Oh, hold on, let me say value equals this. If value is, or yeah, that's how you do it. Runtime error, probably. I'm just gonna do... Perfect. And the winner takes it all. The carryover at max can be 1. It can't be any more than 1. So I don't have to worry about, you know, none of this yabba yabba yabba. Oops. Do I even need to set the thing? Because I do this. Oh, shoot. Okay, so then I'm just basically initializing my next one. I'm going over there. I'm assuming they want me to... Oh, okay, so I don't have to do this in place, because if I have to do this in place, then there will be no return value. Alright, so this will basically add through. Yeah, so if I was to return new head, I think the first case should be fine. This? Okay. What? Oh, wait, huh? So this never runs. Oh, I'm returning none. Fuck. fucking A, man. Holy crap. Output limit exceeded. Oh! Silly guy. Silly Billy. Okay, so this right here, I could definitely see being a problem. So I think at the very end, I'm going to do something like current.next is equal to none. Just to clean up. This is horrible practice. You're not supposed to create something if you're not going to use it. So this is actually a memory leak right here. Horrible practice. But I'm doing it anyway, so hate me. L1 equals L1 dot next. L2 equals L2 dot next. And let's see if I get something out of that. Okay, so I got I know I got that. Okay, so here's how I'm supposed to do this. Here's how I'm supposed to do this. So what I should do is I should store the previous, and then when I create a new one, it's not attached, and then I take the previous and then I attach it. So what I'll do is I'll have head starting off, or I'll have dummy head. So this will be dummy head starting off, and then I'll create a value, and then I'll basically link it, and this will actually be the head. This will be the head right here. And then I'll store this as previous, and then I'll go next, and then I'll keep hopping. So it'll be something like this. So new head. I'm gonna call it dummy head, and then I'm gonna say previous is gonna be equal to dummy head. Okay, and then I'm going to basically do current, it's going to say equals to new, nope, hey, lock in, brother, lock in. New list node, okay. Then I'm going to say previous. So we're going to get rid of this next stuff. We don't need this next stuff. We're going to say previous dot next is equal to current. And then previous equals to current. Run it. Oh! Gabagool, man. Come on. Come on. Okay. That's right. Perfect. That's exactly what I wanted. Alright. Good. So that means I'm on the right track. So now, this is what you do when you're doing merge sort. God, I've done merge sort too many times in my past that now I just have this kind of ideology of the O of n times 3 is still O of n kind of methodology, where you just keep spamming while loops. Works like a charm. I mean, it's kind of how you're supposed to do it anyways. Where you're checking if both are none, then you kind of do a singular operation. I'm doing this even though technically it doesn't really matter. Actually, no, it does matter. It's not right. Hold on. Okay, so this should have a carry over 1, so what I would do is... I think I'm supposed to do... I think I'm actually supposed to do the plus carry over here. I'm not gonna lie, brother. I think I'm supposed to do it here. Oh, yeah. My fault. Forgive me, original gangster. Forgive me. Perfect. That didn't break anything. Thank the Lord. Hallelujah. And I do the same thing over here, but for L2. So I'm basically gonna just do a Control F on that. All right. Okay, so if I run this, it should still be wrong because I'm missing the last digit. Perfect. Okay. So if carryover is equal to 1, then I'm basically going to say I'm going to do current equals list node of 1 and none, and that previous dot next is equal to current. All right, and we're gonna sit here and we're gonna clutch our pearls and hope for the best. Hey, okay, now let's click submit. Please, brother, I don't want to be in refactoring hell. Yes. All right, and that's it. Okay, peak. So that marks 3 today, right? That's 3, right? Yes, that is 3. Oh my goodness, LRU cache? Yeah, you're joking, buddy. No. Hell no. Hell no. Dude, holy hell, this guy's cracked out. Oh my goodness. Oh, bit manipulation? No. No, okay. Oh, these are paid for? Honestly, his explanations are pretty good. His written code, I'm not gonna lie, I don't like it. But he's using too many like N's, A's, L, R. That's like you gotta spell it out so that way I can kind of like read it. You know, I feel like that's clean code practice. But his algorithmic explanation and words is great. It's great. But he's more of a mathematician on that aspect, which is really good. Okay, it is 11:29. That was about an hour long. We got 3 done. Not bad. Not too shabby. I'm going to call it there. Thank you for watching. I'll see you tomorrow.